Uh, चिन्मय सर,
Yes.
या कैन यू प्लीज, आपके पास तो देवाशीष सर का बायोडाटा है ना, थोड़ा बताइए सर को
Yeah,
प्लीज.
yeah, I have it.
या कैन यू
I
प्लीज.
have it. So, sir, sir is there. So I'll start. I'll start from this paragraph that Dr. Devasith Bhattacharya is the Vice President of Technology and New Materials Business Wing of Tata Steel. He is setting up non-steel business such as composites and graphene. He also oversees technology and R&D ranging from raw materials to finished products in the steel and non-steel business. After that, I'll start from his academic background that he started his career with a BE from in metallurgical engineering from Jadavpur University in 1986. Then he moved to IIT Kanpur, Department of Metallurgical Engineering, and obtained his MTech degree in 1989. And after that, he obtained his PhD degree from Material Science and Metallurgy, MSM, University of Cambridge, UK, in 1992. After that, he was research associate at Rolls-Royce Technical University Centre, UK, and he was in Cora's Research Fellowship, and he has numerous awards in to his credit. Of them, he received Metallurgist of the Year award from Government of India in 2004, and then Fellow of Indian National Academy of Engineering (FNAE) in 2008. Then he was an industrial professor in University of Warwick in 2010, and he obtained Fellow of Indian Institute of Metals (FIIM) in 2013. He remained as visiting professor in Imperial College in 2013 and guest professor in University of Technology Beijing, China in 2014. Then I will come to this, that he is a personality with a specialization in physical and mechanical metallurgy of iron and steel, and is rich in skill such as change in management, processing improvement, continuous improvement, minerals, and many more. He has made major contributions in the field of material science by the development of advanced and ultra-high steel products for automotive sector and development of new generation coating on steels. Along with this, there are more than 20 patents and more than 50 peer-reviewed publications to his credit. This one.
চিন্ময়,
Yes, sir.
তিনটে জিনিস। একটা হচ্ছে তোমাকে বারবার ওই তোমার কাগজ থেকে স্ক্রিনে ঘাড় ঘোরানোর দরকার হবে না, তুমি একদম দেখেই বলবে, কারণ এটা সবাই দেখেই পড়ে।
হ্যাঁ স্যার, আমি দেখে দেখেই বলছি।
হ্যাঁ, কিন্তু তুমি বারবার
আমার প্রিন্ট আউট করা আছে।
হ্যাঁ হ্যাঁ, তুমি বারবার ওই স্ক্রিনের দিকে তাকাচ্ছ পড়তে পড়তে।
না, স্ক্রিনের দিকে মাঝে মাঝে তাকাতে হয়, মানে ওই আর কি, যে আমি পড়ে।
কোনো দরকার নেই, তুমি শুরুতে বলবে যে it is my honor and privilege to introduce Dr. Devashish Bhattacharya, Vice President, blah blah blah, যা আছে, ঠিক আছে? এইটা স্ক্রিনে বলে তুমি তারপরে পেপারের দিকে তাকিয়ে পেপারটা পড়ে যাবে। লাস্টে বলবে যে now I would invite Dr. Bhattacharya
to deliver his speech,
to present his lecture. এটা বলবে। আর একটা কাজ করবে, সেটা হচ্ছে আরেকটু স্পষ্ট করে আস্তে আস্তে পড়বে, মানে কথাগুলো না জড়িয়ে যাবে।
না, একদম আস্তে আস্তে পড়বো, একদম আস্তে আস্তে পড়বো,
স্পষ্ট করে বলবে।
একদম একদম একদম।
কারণ কি হয়, অনলাইনে এমনিতেই একটা ট্রান্সমিশন প্রবলেম হয়।
হ্যাঁ,
অনলাইনে তুমি যখন বলবে,
আমি আপনাকে আমি জাস্ট স্ক্যান করার জন্য আমি একটু তাড়াতাড়ি পড়লাম, বাট when I will read it in actual field, I will be like this, that Dr. Devashish Bhattacharya is the Vice President of Technology
নরমালি যেমন চিন্ময়,
এত
আস্তে বলতে হবে না, নরমালি যেমন বলে।
না, মানে একটু একটু আস্তে আস্তে বললে ব্যাপারটা কি, এটা আপনি যেটা বলছেন ট্রান্সলেশন হতে একটা ট্যাক ট্যাক করে একটা কেটে যায় অনেক সময়, কিন্তু সেটা সবাই বুঝতে পারবে আস্তে পড়লে। একটু অপটিমাম স্পিডে পড়বো আমি,
এখনো সেটা হচ্ছে।
এটা আমি তো আপনাকে খুব স্পিডে বলছি, ওই জন্য হচ্ছে আর কি, এর থেকে স্লো পড়তে হবে।
তুমি শব্দগুলো, মানে এটা মিডিয়ায় বলার নিয়মই এটা যে শব্দগুলো স্পষ্ট করতে হয়, দ্যাটস ইট।
হ্যাঁ হ্যাঁ
শব্দগুলোকে
ঠিক
ক্লিয়ার করতে হয়, এটা
ঠিক
মিডিয়াতে
ঠিক
বলার এটা নিয়ম।
ইয়েস
তো ব্যাস ঠিক আছে। আর প্রথমে আর শেষে ওই লাইন দুটো বলে দিও যে it is my honor and privilege to introduce Dr. Debashish Bhattacharya, ঠিক আছে। লাস্টে বলবে যে now I will request Dr. Bhattacharya to present his lecture।
রাইট
ঠিক আছে। আর তুমি প্রদীপ দত্তর লেকচারটা শুনেছো?
হ্যাঁ
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 পুরো লেকচারটা শুনেছো? এইবার তোমার ওই সলিডিফিকেশনের কন্টেন্টটাকে এখান থেকে কিছু মেটেরিয়াল ঢোকাও, একটু থার্মাল ব্যাপারটা ঢোকাতে হবে ওখানে। মানে আমরা যেটা তুমি যেটা লিখেছো সলিডিফিকেশনের, ঠিক আছে, ওখানে এই রিলেট এখান থেকে কিছু মেটেরিয়াল তুমি ওখানে দিতে পারবে, বুঝতে পেরেছো? আমি ওই জন্য ভাবছিলাম যে তুমি এই লেকচারটা শুনলে কিনা। ভদ্রলোক ভারী সুন্দর মেটালার্জিক্যাল সায়েন্স আর মেকানিক্যাল সায়েন্সকে একটা ফিউশন করেছেন।
সবাই করেছে কিন্তু starting from the beginning everyone almost every speaker they are speaking see without metallurgy you cannot escape I mean advanced manufacturing
উইদাউট মেকানিক্যাল ব্যাপারটা এরকম নয়। ম্যানুফ্যাকচারিং ইজ এ ডিফারেন্ট গেম।
yes
হ্যাঁ, ওই তিনটে যে আমরা ভেন ডায়াগ্রাম করি না, ওই তিন চারটে সাবজেক্টের যে ওভারল্যাপিং জোনটা, সেইটা হচ্ছে ম্যানুফ্যাকচারিং।
yes
সেইটাকে লোককে বোঝানো দরকার। লোকে ম্যানুফ্যাকচারিং মানে মেকানিক্যালের একটা সাবসেকশন ভাবে। টিল দ্যাট পিপল কনসিডার manufacturing is a subset of mechanical engineering.
no not subset it is I mean everything is a subset of everything.
The whole purpose of organizing this course is to establish that, and that's how all the speakers have been selected.
Yes
খালি একটা বাদ চলে গেছে, one lecture I have missed, that is automation.
হ্যাঁ
automation automation বাদ চলে গেছে, সেটা আমার মাথায় আসেনি। তো যাই হোক, পরে আমি করবো এটা। অটোমেশন এক লেকচার होना चाहिए,
মানে starting from মানে manufacturing when somebody is somebody is I mean programming it in computer, the computational activity also they are considering that Abraham GMK equation and Abraham equation and all these things, okay, and TTD diagram, everything. I mean you cannot escape those things. This is the basic. From there everything starts.
না আমরা ওখানে ঢুকতে পারি না, যার জন্য মেটালার্জি সাবজেক্টটা মার খেয়ে যাচ্ছে। হ্যাঁ, আমরা ওখানে ঢুকতেই পাচ্ছি না। হ্যাঁ, সিএফডিটা মেটালার্জির জন্য এত ইম্পর্টেন্ট, কিন্তু আমাদের কোনোদিন পড়ানোই হয়নি সিএফডি। যাই হোক, ঠিক আছে। তুমি ওই সলিডিফিকেশনটায় প্রফেসর প্রদীপ দত্তর লেকচারটা ফলো করে সেখান থেকে কিছুটা, মানে যেখানে মেকানিক্যালের সাথে জোড়ে আর কি, থার্মাল ইঞ্জিনিয়ারিং এর সাথে জোড়ে ওটা, সেটাকে করতে হবে। যাই হোক, আমিও করব। আমি আসলে সময় পাচ্ছি না এইগুলো করে। ইউনিভার্সিটিটা হয়ে গেলে, যদি হয়ে যায় আর কি, তাহলে এগুলো আমি ছেড়ে দেবো। তারপরে আমাকে করতে হবে। ঠিক আছে।
Good afternoon, Dr. Bhattacharya. Tanmay sir.
Am I audible?
Yes, yes.
Tanmay?
Yes, sir.
Tanmay, am I audible?
Yes, sir.
আরে চিন্ময় নয় তন্ময়।
Okay, okay.
তন্ময়, I find you online. Are you getting me? আরে তন্ময় ভিডিও অডিও সব আনমিউট করে রেখেছে। মিউট করে রেখেছে। তন্ময় কি ফোনে কানেক্ট করেছে নাকি? না, তোমাকে তো দেখা যাচ্ছে তুমি কানেক্ট করেছো, তুমি অডিও ভিডিও অফ করে রেখেছো, করে রাখতেই পারো। আর তোমার কলিগরা পেয়েছে? হ্যাঁ হ্যাঁ, ঠিক আছে। হ্যাঁ হ্যাঁ, রিজিউমে পেয়েছি, চিন্ময়কে দিয়ে দিয়েছি, চিন্ময় মুখস্থ করে ফেলেছে। আবার চিন্ময় নিজেও কিছু কিছু ঢুকিয়েছে। চিন্ময় কলেজের ছেলে তো। চিন্ময় যাদবপুরে?
না, 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 স্যার।
চিন্ময় তুমি এনআইটি দুর্গাপুর তো?
হ্যাঁ, হ্যাঁ, হ্যাঁ।
ও, তুমি আমার ছেলের কলেজে যাচ্ছে। ও বাবা, চিন্ময় হচ্ছে দুর্গাপুর, হচ্ছে কমনীয় চট্টোপাধ্যায়, বিক্রমজিৎ বাসু
ডন জায়গা স্যার।
চট্টোপাধ্যায়। ও ও ও মহা কুড়ে, ও লড়বে না তো কি করা যাবে। ও বুঝে গেছে ওসব করে কিছু হবে না। হ্যাঁ, ও আরামসে আছে। না, তবলাটা ভালো করে বাজালো। অনিন্দ্য চট্টোপাধ্যায় ছাত্র, জানো তো? হ্যাঁ, ও না তবলাটা বাজায়। Chinmoy. Dr. Bhattacharya, you are here? Devashish Bhattacharya.
Yes, sir.
Tanmay, are you getting me? You unmute your device. Tanmay.
Yes, sir. Yeah, I was muted.
Yeah, just check whether Devashish has logged in successfully.
Okay, I'm checking. Waiting. আপনি জয়েন করতে পেরেছেন? জুম অ্যালাউ করছে না।
He needs to log in as a panelist.
Sir, he is not able to get into Zoom. So check about that. So here we are trying. Actually, I was told that you cannot join through your laptop or mobile. But yeah. That, so he is trying through his iPad. Thank you, sir.
उसके साथ जूम का कुछ प्रॉब्लम हो सकता है।
Zoom is not actually supported on our platform. So he is trying to use iPad.
জুমে কোনো সমস্যা হচ্ছে? আচ্ছা। না, ইউটিউব থেকে যাবে না, ওকে একটা ওয়ার্স্ট কেস ও তো স্ক্রিন শেয়ার করতে পারবে না, এমন একটা ডিভাইস লাগবে যেখানে স্ক্রিন শেয়ার করতে পারবে। আর না হলে তুমি একটা কাজ করতে পারো, ও বাবা সেটা এখান থেকে অপারেট করাও মুশকিল। তুমি ওকে কোনো একটা তোমার কোম্পানির ল্যাপটপ ছাড়া অন্য কোনো একটা ল্যাপটপ অর্গানাইজ করতে পারবে না?
मोबाइल से कनेक्ट करके हो जाएगा।
হ্যাঁ, অন্য ল্যাপটপ থেকে দেখতে হবে।
So good afternoon all the attendees. So there is some connectivity issue, so we'll take another 5 minutes. Please bear with us.
Hello.
Yeah.
Can you hear me?
Yeah, good afternoon. Welcome.
Oh, good afternoon. Oh, I'm very sorry. This is a terrible sort of system. No, the system is not bad. We are configured in such a way that we can't speak through Zoom, right? So we have to take a bypass. So I'm very sorry for this delay.
Right. It was same for the government platforms also earlier, but now somehow we have come over it.
Yeah, so we use mostly Teams and WebEx. So we don't. I'm so sorry for taking so much of time.
It is absolutely fine. Chinmoy, I'll request you to introduce Dr. Devashish Bhattacharya.
Okay, sir. Thank you, sir.
Thank you.
Good afternoon to all of you. I am Dr. Chinmay Chattopadhyay, Assistant Professor of Department of Materials and Metallurgical Engineering, NIF Ranchi. This is my honor and privilege to introduce the eminent metallurgist of our country, Dr. Debashish Bhattacharya. He is the Vice President of Technology and New Materials Business Wing of Tata Steel. He is setting up non-steel business such as composites and graphene. He also oversees technology and R&D ranging from raw materials to finished products in the steel and non-steel business. Dr. Bhattacharya started his career with a BE in metallurgical engineering from Jadavpur University, Kolkata in 1986. After that, he moved to IIT Kanpur, Department of Materials and Metallurgical Engineering, and he obtained his MTech in 1989. After that, he obtained his PhD from Department of Materials Science and Metallurgy in the University of Cambridge, UK in the year of 1992. He remained as a research associate in Rolls-Royce University of Technology Center, University of Cambridge, and Pura's Research Fellow. And there are numerous awards. He is a recipient of numerous awards. To name a few, he received Metallurgist of the Year award from Government of India in 2004. He received Fellow of Indian National Academy of Engineering, FNAE, in the year of 2008. He received Fellow of Indian Institute of Metals, FIIM, in the year of 2013. He remained as Industrial Professor in the University of Warwick, UK in 2010. He remained as Visiting Professor in the Imperial College, London in 2013. And he remained as a Guest Professor of Science and Technology in Beijing, China, 2014. He is a personality with specializations in physical and mechanical metallurgy of iron and steel, and is rich in skills such as change management, process improvement, continuous improvement, minerals, and many more. He has made major contributions in the field of material science by the development of advanced and ultra-high steel products for automotive sector, and development of new generation coatings on steel. Along with this, there are more than 20 patents and more than 50 peer-reviewed publications to his credit. Now, I would like to invite Dr. Bhattacharya to present his lecture. Thank you, sir.
Thank you very much. Thank you, Dr. Chinmay. And it's a great pleasure to be here, and it's always a pleasure to be in touch with Professor Chattopadhyay. It's my honor to be here. I'm terribly sorry for the delay that I caused because of our systems. I apologize to the listeners who have been waiting patiently. I don't know if they're waiting impatiently. I can't see them, but thanks for waiting anyway. So I'll, without further ado, by the way, how much time do I have?
1.5 hours, sir.
Okay.
1 hour 30 minutes.
Okay, and that includes the question answers, right? I will go to the share screen and see if that works. And you can hear me perfectly, or
yes,
do I need to speak louder?
Yes,
or yeah. So let's go to the screen, see what comes up. I need to share screen, right? Share content.
Share screen, sir, in the bottom ribbon. In the bottom ribbon, you can see share screen.
There's no, my things are coming on the top.
Okay.
So there's share content. iCloud Drive. Yeah. Okay. Good.
So at top,
can you see my screen?
No, sir.
Why
Yes,
is
sir.
this screen
Yes, sir.
recording?
Below there is an option called share screen. You are getting at top, sir. Huh?
I'm getting share content option, stop video, mute
No,
participants.
No, sir.
Where's
Share
the
screen. It is written share screen. See, green
share
color
screen.
button.
Should be there.
Green color button.
Green, right?
Green color button. It is written share screen.
Yeah, yeah, okay. It says so. So I'm there. Photo, Chromecast. This is terrible.
It is flip button from the left.
The what, sorry?
It is flip button from the left.
Yeah, I see that.
It's a green button with an arrow mark.
Share करना. Now
Okay.
I think yeah, I think it started coming.
Can you see? Can you see
Yeah,
the screen?
It's popping up.
So it says materials challenges for advanced manufacturing.
Not yet, sir. Not yet.
Something is happening.
Yes, something happening, but not the screen has not appeared yet.
Screen has not appeared yet. Yes. I'm sorry, our systems are not configured for Zoom, but it should still work.
Yeah. So are you using Zoom through web or with some apps? Sir? Zoom app
From the web.
from the web.
The app, it won't. My computers won't allow me to use.
Ah,
No, no luck.
no luck.
Okay, let's see.
You can project if you share.
Anything better? What are you seeing on the screen?
Not yet, sir.
Yeah, this is Tanmay. I have a suggestion.
Yeah.
Tell me.
So, if the presentation already shared by Dr. Bhattacharya,
Yeah.
if that is presented, will it do?
No, no, not that one. It's a different presentation.
Not that one, it's a different one. Huh? Okay. Okay. Thank you.
So,
Shall I send it?
can you share your presentation with us so that we can present it from here?
I'll do that straight away.
Then definitely I'll be able to manage it.
Yeah,
Yes.
yeah, that will be fine. Yeah.
आपका mail से forward कीजिए. ये yeah.
Okay, I've just sent. Can you still hear me?
Yeah, we can hear you, sir.
It's a largish file.
Yeah, which ID is it?
I've sent it to Professor Chattopadhyay.
Achha, director.nift or partho.basis?
It's gov.nif, ppc.
Right.
Yeah.
It
Yeah,
is still on the way.
it's gone. It's gone from me, so it's on the way.
It is still on the. It is after all .gov.
It's a PDF file. Can you see me also? Or not yet?
Not yet, sir.
You can hear me. Good. At least.
So is it you have started sharing, but it's not coming up like that?
Oh, okay. So it's stuck somewhere.
It's stuck.
I want to Google now. I presume you can see me now. I think that's
Yeah, we can see you.
No, we can see you.
Presume you can see me now.
We can see you, sir.
So we have got the presentation. Just wait a couple of minutes more.
So sorry about all of this hustle. I think our systems make it very difficult for us to use Zoom.
Full screen, full screen.
Mm-hmm.
Yeah, it's titled obviously as NIFFT.
Yeah, correct. नहीं वो खुल रहा है मैं जो प्रोजेक्ट मोड पे कैसे आता है वो हाँ PDF है just go back to
Okay.
okay so we need to do like this, huh?
Mm-hmm.
We need to do page
You
I'm doing it. Yeah, so I'll start sharing this.
Sure, okay.
Just tell me, just give us a signal when to change this slide.
I will do that.
Nice.
I hope you can see
Material
this.
challenges for advanced manufacturing.
Oh,
Dr. Devish's button.
that wasn't my voice.
Yeah, we are all set to go, sir.
That is okay. Don't worry. Don't worry. That's the least of the problems. Okay. Yeah, bye. Yeah. Can I start or?
Yeah, sure.
Okay, good. So thank you again, and apologies for all this time taken for setting the talk up, and also for me to get in. And thank you for your patience. So I'll be talking on materials challenges for advanced manufacturing, and I'll be using this as a as a guidance to what I'm going to talk on. Can you go to the next slide, please? So most of my coverage will be on how manufacturing, on initial part will be on how the whole chain of manufacturing is changing, because manufacturing is not for the sake of manufacturing. It is to generate wealth. And manufacturing is a part of the whole value system, the value chain that generates wealth. The first part of the talk will be to see how that whole chain, the value chain, is transforming itself. And then we will go on to talk about certain specific materials and the challenges in the manufacturing, also some of the advanced materials, advanced manufacturing technologies, and the challenges specifically to the Indian, reference to the Indian context. And we'll end up with, by talking about what we can possibly do. There may be multiple ways forward. I will just talk about maybe a few. Okay. Next one, please. Yeah, thank you. So the way manufacturing is transforming today, it can be clubbed in many ways, described in many ways, but I put it under 4 trends, 4 mega trends, if you wish. The first is consumer demand itself. The nature of consumer demand is changing, and it has changed over our lifetime. And I'm talking about people who are above 50, above 55, who have seen, I think, who started who were young when mobile phones were not in existence. We used to wait for a couple of years before we even got a landline phone. So that generation has seen multiple transitions in the nature of consumer demand. We were happy if we got a mobile phone, if a phone connection in 2 years. Today, people change 2 phones in 2 years. So that is one of the indicators of how manufacturing technology has changed and how consumer expectation has changed. If an app doesn't update itself every couple of months, we think probably the company is dead. The nature of products themselves are changing. It's changing in the way, in what it's offering. I'll talk a little more about it later. The economics of the value chain is changing, and it's where wealth is made and how do you tap into that wealth. That concept is changing, and of course, the economics of production itself is changing. And we'll talk a bit about that. Can you go to the next slide, please? And we'll talk about the consumer demand. If you look at household today, and it is live today, right? You can choose, not in all parts of the world, but definitely in some parts of India, you can choose, for example, what combination of electric suppliers you want to take your electricity from. So we have, for example, a company in Bangalore, a composite company in Bangalore, which can choose to use a certain provider of electricity because he has that particular service provider, electricity provider, has more fraction of renewable energy in its basket, and therefore our load on using renewable energy goes down because we are using more renewable energy in the grid electricity. So we can make a choice. Imagine a few years back, we were just stuck to either CASC. Today, still we are here, CSC or WBSCB, which is people from Calcutta will know, but in this general context, global context, it's Calcutta Electric Supply Corporation or the West Bengal Electric Supply Corporation. No more today. In many parts of India, many parts of the world, you can choose which power supplier, utility supplier you want to take electricity from, or for that matter, any utility from. Right? So I can customize the nature of electricity I'm going to buy from the utility service provider. I can therefore extend this to other consumer demands in demanding utilities, in demanding transport services, in demanding whole plethora of goods and services. The consumer today is a co-creator along with the manufacturer, and unless the manufacturer is aware of that, the manufacturer will be caught in a time trap. Next one, please. Yeah. Let's look at the products, the changing nature of products. Gone are the days when the watch was a watch. Yeah. The watch or the camera was a camera, or the mobile phone was just a phone. Yeah. Gone are those days. The photo on the left shows those like smartphones. They have become smart watches. And these watches, besides just telling time in a boring sort of way, they also tell you your heartbeat if you want to know. They also tell you the number of steps you have taken in the day. They'll tell you how many steps you have climbed during the day. They will today, in fact, one I bought recently also tells me my oxygen content in the blood, which is very pertinent for these days. So just from a dumb watch, it's become a smart device that helps me in knowing many things which I didn't even care to know a couple of years back. But now that I know, I can't do without it. Right? Every time I walk outside, I look at the watch to see how many steps I have done and how many steps I'm away from the 10,000 steps that somebody has told me is good for me. So you can imagine it's a catch-22. So a device comes in with a new offering that becomes a part of my life, and that becomes my expectation for the next product. So you can call it a virtual cycle that keeps the products from offering more and more facilities, if you wish, on the same device. The product has now become a platform also. And you can imagine if it's a watch, it's not just a timekeeping device, it's a health monitoring device, but it's a platform on which others can build apps to give things that you didn't even know you needed. Yet when you get it, you think, yeah, that's very nice. So the same thing has happened to mobiles. It's gone from being a camera, a mobile phone, to being a camera, to having pages and pages of apps which give you music on the go, which give you news on the go, and whatever else that you may not need on the go. And that's just soft form. But today, Google is coming up with a mobile phone that is modular, and it is modular, and it is a platform on which other service and product providers can add their products and services physically. So that's a platform that's being created out of a product. And you can imagine, you've already seen how platforms are being transformed into services. So is Uber a taxi service? Is Uber a convenient mechanism of transport, of your relocation from point A to point B in the most convenient sort of way? So it's like going to an app and saying, I want to fly. So going to booking.com and saying, I want to fly from Calcutta to London. And booking.com will tell you exactly which combination of flights to take, which is the cheapest route. And then it will give you a comparison of other routes. It will tell you which hotel to stay, which car to hire, everything. The Uber platform of products is exactly that. It gives you a service from going from point A to point B, or even taking your material from point A to point B in the most convenient sort of way from an app. You don't need to buy a car, you need to own a car, you don't even need to know the driver. So the transition that is happening in products is very clear to us. And obviously it has a bearing on core manufacturing and what we mean by a product. Next, please. Yeah. Along with this change, the change in the nature of product, what is also changing is the economics of the value chain. If you imagine the value chain, you have raw materials, which is converted into some metal or plastic, which is then converted into an object that a consumer uses. It is then taken by an intermediary to a retailer, and then it's bought from a shop by a consumer. Now, what is happening is people are now looking at the whole value chain and seeing where is wealth being made, money being made in this whole value chain. It is not necessary that the money is being made by the raw material producer. It is not necessary that money is being made by the final end customer, by the retailer. It may be made somewhere in the middle. You can imagine where money is made in agricultural products, most of the money. You can imagine where most of the money is made in airline industry. You would wonder, why would any airline fly? Because most of the money is not made by flying an airline. It is not certainly made by manufacturers of the engines. So you have to go to different business models. You have to reinvent the business models to make money, to get wealth out of the value chain. So engine manufacturer, for example, Rolls-Royce or GE, cannot make money by simply selling an aircraft engine. They make money by giving annual maintenance contracts. So their engines, essentially, the business model has graduated from giving annual maintenance contracts to simply leasing the engines. So you would lease for a period of time, and the money you make is in reducing downtime. So you give reliability. So earlier, when engines in aircrafts used to be overhauled every 7-8 months, which meant downtime for the flight, and the flight only makes money when it's flying, not when it's on the ground. That transformed. So when the engine makers started selling reliability by leasing out the engines, they made money while the engines were flying. So they made sure that the engines were very, very, very reliable. The manufacturing technologies were very reliable and up to a standard. The materials that they used had lifing, which was very reliable. And today, the overhauling period has now increased from 7 to 8 months to 7 to 8 years. In the meantime, of course, the people are not blind. They have sensors which keep on detecting the state of the engine and keep on giving feedback. So peripheral technologies have changed, have transformed, have improved to give enough information so that you make money in a business model through a manufacturing and service offering in the whole, that influence the whole value chain, economics of the whole value chain. In a way, you've also taken out intermediaries, people who used to, there were companies which used to come in to do the overhauling and the maintenance work every 7 to 8 months, would find their business dwindling because they now are needed only once in 7 to 8 years. So there is a whole transformation that happens. Next one, please. Similarly, it happens in the clothing industry also, and it's already happening with certain brands coming onto the net and saying, can the consumer co-design the apparel that the person wants, that the consumer wants, with the designer, and the brand then comes in and says, okay, we will manufacture it, this is the price, and oh, there's a certain royalty for the designer. And because it's bespoke, people will pay, right? So now you can imagine the impact of this on Main Street retailers who have just one size fits all sort of offerings. So there's a transformation that's happening in this space as well. Next one, please. Yeah. So now we come to the economics of production, right? We have seen multiple changes happening. We know the IoT, and I'm not going to talk about IoT because one of the talks either before me or after me will be covering that. But over the last, at least the last 30 years, we have seen the impact of Moore's law. How fast computers and anything related to computation has moved forward, has improved in performance, and has reduced in price. Absolutely following exponential laws. So robotics have come in a huge way. Of course, in manufacturing, definitely, and they're making slow ingress into the space of human beings also. And along with this will come additive manufacturing, which saves time, which saves material definitely, but not being subtractive, not being machining. And we'll talk a little bit about that later. Next one, please. Yeah. And enforced by all of this have changed materials. Most of the stuff that we see around us today are multi-materials, and progressively they are more and more advanced materials. If you look at, if you take out, break down a car, for example, of today, let's say an Audi A6 or a BMW 5 or whatever, you'll see the extent of use of multiple materials has increased dramatically over the last 10, 15 years. An ambassador used to be made of basically, you know, if you look at it, just the skin, 2 types of steel or 3 types of steel. Today, there's no ambassador, but a decent mid-level, mid-range car will have steel, will have aluminum, will have polymers, will have composites, steels of at least 5 or 6 different grades. You'll have coated, you'll have uncoated. The whole, and this is just a car. And if you look at the transition that has happened in telecommunication, in just the handheld telephone, the materials used inside has ballooned over the last 15 years. Partly, of course, driven by Moore's law. So we'll talk about material science a little more later. Yeah, thank you. Next one, please. Yeah. And of course, all of this has been aided by internet. Although we had a problem with on getting into Zoom, but this is the way forward. We have seen, you know, whether we are meeting amongst friends or we are having official meetings over Zoom or Teams or whatever, forward. And this is how people are very conveniently interacting and exchanging information. They're also exchanging information on manufacturing, where you can have a concept and design at one place, manufacture at a completely different place, in small scale or even in large scale. Distances have crashed, and production chain from concept to design to manufacture to market has transformed since what we had, say, 10, 15, 20 years back. Next one, please. Well, I think here I will give you an example of Tata Steel's own experience in new materials business, which we started 1.5 years back. We started to explore the business 1.5 years back, 2 years back. We went into business 1.5 years back. And without any investment in asset, without any asset ownership, this business has grown 10x over the last 18 months. Right? It has designed products. It has ridden on existing products, introduced completely new to the world products in sectors of industry, infrastructure, and railways, and having a growth rate of 10x in the first 18 months of the business without any capital investment shows that there are now business models possible which are eroding away and barriers to entry. In the yesteryears, you couldn't start a business. You couldn't have thought of a materials production business, without capital investment. Today, you can. And this business is growing very rapidly today. And similar models are applicable across the group, across the globe, in multiple materials. Next one, please. I think next one we'll skip over. We've spent enough time on business models and the value chain. We'll go to the next one. Yes, thank you. So we'll now look at individual materials and see what can be done in the Indian scenario from the production and manufacturing perspective to make India self-reliant and world leader in those materials. And of course, the materials chosen are either of strategic nature or of a nature which would make India, would take India to a leadership position in materials that are emerging and have tremendously high applicability in multiple areas. So we'll start with, next one, please. Yes, thank you. We'll start with titanium, which is a strategic material. India has the third largest ore deposit of titanium, which is in the beach sands, mostly in the southern part of India, but it works its way up the east coast. Having third largest deposit in the world, India makes 500 tons of titanium in a plant, in a plant which is owned by the government, not necessarily the central government. It probably is owned by the Kerala government, but it's government owned. Compared to a global production of 75,000 tons, annual production of 75,000 tons, which means India makes less than 1% of global production, having the third largest deposit of ore. And of course, 500 tons is not an optimal size. Right? So no wonder it is not competitive today in terms of price or the cost at which this material is produced. There are certain recycling units that need to be put in place, but for that, the whole business to become really attractive and have a strong business case, you need to scale up, and that scale up needs to be done either by the government or by joint effort of the government and a private industry. But it's a space which is a gap in the Indian materials manufacturing scenario. If you go to the next slide, please. Yes, you'll see that the demand for titanium is increasing in the aerospace sector. This is just example of Boeing and Airbus. And as you move from left to right, you'll see the more newer models of Boeing and similarly the more newer models of Airbus. Excuse me. The new versions, as you can see from the encircled areas, have more and more titanium. And so, of course, it is driven by composites. The use of composites, especially carbon fiber composites, has gone up to about 50% in the newer aircrafts. And of course, carbon fiber famously does not go along with aluminium because there's a corrosion issue. So the choice for a metallic goes to titanium, where the demand for titanium therefore has risen, driven by aerospace. And if India wants to become a hub and wants to make its own military aircraft, or also civilian aircraft, maybe small versions, this is the way forward, and we need to have our own titanium, along with carbon fiber, which I'm going to talk about later. Next one, please. Now, titanium, of course, has a this is for the metallurgists here who understand the alloy phase diagrams. Like steel, and unlike aluminium, most of aluminium, titanium has a very flexible phase diagram, which means that you can give titanium different properties, strengths, hardnesses, ductilities by giving different heat treatments and having different precipitates, different phase combinations. Next one, please. So it's a very versatile material, therefore. But then its price has to come down through scale. Its price has to come down to a manufacturing route that can bring down its cost of production. But for that, India needs to invest in intellectual capital, in research capital. These are some of the products that India could design, develop, and manufacture and sell to the world, either from the health sector or in the aerospace sector. Next one, please. But if you look at that value chain, of titanium, you start with basic knowledge. There are hardly any academic groups in India which work on titanium. There are some pilots, and I would think a 500-ton plant is a little more than, it's a commercial plant, but it's not really commercially viable. It's a big pilot plant. So we have experience in running plants and pilots in titanium, but there is lack of basic knowledge and basic research in titanium. Manufacturing, we need scale. But the whole point is that the market in India is not big enough to pull this whole value chain. Right? The Indian aerospace and medical sectors are weak in terms of amounts that they manufacture, that they make. So they need to pull. Therefore, our focus, in order to have a natural pull in this material, is to create the market. Of course, creating a market in India would be difficult, would be slow. So maybe we should transform our vision from being India-centric in our market to being globally focused on the market. So we could make in India for the globe. And that is the way by which we can pull this whole value chain of titanium from demanding more amounts of titanium, which could mean scaling up in India, which would mean requirement for qualified engineers, requirement for intellectual research and technology inputs, which would mean development of research groups in the academia. So on titanium, I would end by saying we need to look global. And I think some of the materials, the answer is that we need to look global for the market. Next one, please. Carbon fiber. So this is another strategic material. And yes, please go to the next slide. Thank you. This material, which in 2018, the world made about 90,000 tons. And the way the people are putting up plants across the world, it will grow to about 200,000 tons by 2025. Most of it is being used in aerospace, and I gave you some examples of Boeing and Airbus. The whole fuselage is turning into carbon fiber. It's being used in automotive and wind. As the windmills increase the lengths of their blades, no longer would they be made of glass fiber. Anything above 80 meters, 90 meters would have to be carbon fiber to reduce weight on the bearings. Automotive, it's price sensitive, but as the prices are coming down, uptake in automotive will increase. And my opinion is, if price of carbon fiber comes below $10, it will have a significant uptake in automotive. And of course, once there's a volume uptake, there will be further decrease in price. And sports. If you go to see the Indian picture, next one, please. Next one, I'll skip this. Thank you. If you see the Indian picture, right? India makes, or India consumes today about 750 tons. The M is not million, it's just metric. So 750 tons out of the, say 100,000 tons. So again, less than 1% of global consumption. And that's not surprising. The same story as titanium. The users of these materials, strategic materials, although this is strategic, but the market is still small. Our aerospace market is small. The automotive or the wind market, compared to the rest of the world, is small, and most of the wind blades that we use, the lengths that we use, are sufficient for to be designed and manufactured in glass fiber. So all in all, this materials consumption in India is less than 1% of global consumption. Right? With this sort of a market in India, there's no way that we can have large-scale production, or any company is going to set up large-scale production for the Indian market. So the answer here is also that if we want to be self-sufficient in this strategic material in a self-sustaining way, we need to create the pull. We need to create the pull partly by having manufacturing of the aircraft components in India, increasing manufacturing of aircrafts in India, or treating the globe as our market. India has certain inherent advantages in this material. One of the key issues with traditional carbon fiber is that it uses acrylonitrile. Again, it's the raw material is it is mostly imported, although it can be made from most of the petroleum as a petroleum byproduct. But it is it has some specific sources. Our academic system, again, support system in this material is weak. If I go to the next slide, we'll talk about it in a little more detail. Next one, please. Next one. Yeah. Previous one. Yeah. There are various levers that India can use to address carbon fiber and to be globally competitive in carbon fiber. One, of course, is the largest part of cost of carbon fiber is in the polyacrylonitrile, PAN, the raw material. There's, of course, a power cost and there is a manpower cost. On two of these, is the PAN, the cost of PAN and the cost of manpower, India should be able to create a differentiation. And let me talk about PAN. Of course, polyacrylonitrile has been the preferred choice for decades, and the technology has developed using polyacrylonitrile, and all the high strength grades that we see, the T780s, T900s, are from PAN. Coal tar pitch is also a source of carbon fiber. Not much work has happened in this area. The little bit of work that has happened mostly in Japan, Nippon Steel, Mitsubishi, and some plants in US have worked on coal tar pitch, have produced high modulus carbon fiber, which has its own value, but not necessarily to the strength levels of T900s, etc. But that's a matter of how much research you put in. But imagine, let's focus on coal tar pitch. Steel plants make coal tar while they make coke from coal. So for every steel plant, coal tar is a byproduct, which goes to make many other things, of course, but mostly low value things. But imagine if you could take the coal tar and convert it into a low QI, which is quinoline insoluble portion, or the low QI coal tar, and there is technology for that. And then you distill the pitch out, which is isotropic pitch. You could then have a mesophase pitch, which will give you a green fiber, which can be treated to make carbon fiber. This process is entirely possible in India because India is a growing country in steel manufacture. And it will have a whole lot of coal tar available today and going forward over the next few decades. So if we internally can master this technology, we have then a leadership position in the world to make carbon fiber from coal tar pitch, which will be different, which have a different price point, which will have a different characteristic compared to PAN-based carbon fibers. And of course, then we have to work out how to use this carbon fiber. That's a matter of technology development, which should pull research into academia and research labs. Excuse me. Next one, please. A big issue in composites is recycling. Now, there are technologies which India can adopt, adapt, develop for reusing, for reclaiming and reusing carbon fiber, either from the unused prepregs. Prepregs are pre-resin impregnated fibers, and taking them through chopping them into small pieces, then giving them an in-mold treatment to make products for automotive, railways, and other sectors. If we master this technology, we can be a world leader in an area which is really waiting for leadership to be taken in recycling of composites. Next one, please. So these are some of the components which can be made from recycled carbon fiber. You can make seat backs of automotive, you can make automotive car hoods, you can make oil pans or sandwich panels. These need not always be exposed surfaces. These can be internal surfaces and have same strength and lightweight that you would need, but at a much lower cost. So we could use a recycling technology to our advantage to make products out of carbon fiber at a price point which can then lead to a large market for carbon fibers. Next one, please. And then if you see the same value chain of carbon fiber as we showed for titanium, basic knowledge, there's hardly any group in India that's working on the fundamentals of carbon fiber. There's pilot plant available only in NAL, in Bangalore, and that's been there for a couple of decades. At least I know of it being there for a couple of decades, and it is trying to get a hand-holding from industry, but has not been very successful. And of course, there is no big manufacturer in India of carbon fiber. It's not that attempt has not been made, but has not been successful. And one of the biggest hindrances is the lack of market. And again, the same story as in titanium, we need to think of the globe as the market. And then we move ahead and we see how that market pulls and how we can create manufacturing base in India, which will enable us to make this very strategic material. Next one, please. Let's touch upon magnesium, another strategic material. 85% of world's 1 million ton production of magnesium is from China. And it predominantly uses the pigeon process, which is environmentally unfriendly. It guzzles energy and is a process that in many countries would not be allowed simply because of its adverse environment footprint. But lo and behold, 85% of this material comes only from one country. Next one, please. Now, there's an opportunity to take leadership, for India to take leadership in this. We need to innovate and find out ways of using local materials. India has a strong, and just I'll give you one example on this, not many. India has a strong ferroalloy industry. The ferrochrome and other ferroalloy slags have a large amount of magnesium oxide. And this magnesium oxide, this magnesium bearing slag, can be treated while it is liquid. So you preserve the heat and you don't need to reheat again. And distill out the magnesium under vacuum, which can then give you a high quality magnesium. I'm sorry if I've used manganese in my talk. It should be, I meant magnesium. So you distill out the magnesium from the slag while it is hot, and you get a magnesium that has a minimum pollution footprint. It needs no calcination. It hardly needs any additional heat because the slag is coming out at about 1600 degrees centigrade. It needs vacuum for the distillation. So this is a technology that is being tried out today, and a pilot scale. and has the bearings to becoming a competitor to the cheap pigeon process based magnesium that's coming out of China. And we need to think in this way to use local raw materials, local products to make materials that will help India becoming a leader in these metals. Next one, please. Additive manufacturing. Next one, please. This is an area that has been growing almost unnoticed. People have been talking about it. Not many really knowing what to do with it. Till General Electric took it up in earnest and created fuel nozzles for the LEAP engines, and that was really successful in creating reliability and downscaling the engines to the sizes required. Lo and behold, the largest activity in 3D printing is in Northern Europe and Northern America and Europe. Of course, success leads to success, and you can see that over a period of 7-8 years, the total market for 3D printed objects has ballooned from roughly $1 billion to going to be around $26 billion this year or next year. That's a huge increase, and by all measures, additive manufacturing is here to stay. It will become competitive. And go to the next slide, please. Yeah, it will become more and more competitive. It's today used mostly in automotive or consumer goods, in other businesses, in healthcare, and it's used in either metallic form or in the polymeric form, mostly for complicated small volume components. But as we go along, the next page, please. Yeah, as we go along, it will become more and more commercially viable as more, we talked about how consumer behavior is changing, consumer demand is changing, and how the consumer wants to co-design with the manufacturer. So we were thinking, for example, in a workshop with Tanishq, could we have 3D printers in Tanishq shops in city centers, right, on the main streets? So you would come in with your with a need to buy an earring or a necklace, and you would look at a catalog and say, okay, that's what I want, that's what I like, and you'll go off shopping, and there would be a printer in the Tanishq shop which would print the object that you want, to the size that you want, and the design that you want. And when you finish your other shopping, you come back and you collect your jewelry. It's not there yet, but I'm sure something similar would happen in not too far distance of future. You can imagine it's doable, right? And it will transform the way you order jewelry, you manufacture jewelry. Gone will be the days when people sit and file meticulously at very small scale with very nimble fingers. So this will enable faster time to market. This will reduce cost of ownership. It will be extremely customer friendly. It will. You can imagine what will happen to the whole value chain of jewelry, where the wealth will be generated, and what sort of transformation this will create. And it's a similar stuff will happen, has already happened, or is happening in the aerospace engines area. It will happen in automotive, etc. Next one, please. The key element, excuse me, in additive manufacturing is, besides the way you are laying down the powder, is the powder itself. And India today has a dearth of powder manufacturers. It's a quality and in terms of chemical composition and the physical dimensions of the powder determine how precisely you can control the product that you've made in terms of surface finish, in terms of mechanical properties, etc. Today we are dependent mostly on imported powder, and mostly it comes together as an offering with the machine. You can't get out of that handshake. It's like buying computer printers and being tied up with the printer manufacturer for the cartridges for the rest of the life of the printer. Next one, please. So it is important. This I've covered. Next one, please. I'll talk about it later. So we'll go to the next slide. Yeah. So in the Indian context, excuse me, there are very few domestic powder manufacturers. We need to be strong in this. We're today dependent on high-cost imports, on long supply chains, depending on the supply times that are dictated to us by mostly the machine manufacturers. Because again, the volume of additive manufactured products is low in India, the business case for powder manufacturing is perhaps not high. And again, the same value chain effect, we are limited in R&D and customized powder development. And added to the fact that there is a huge need for developing our design capability in additive manufacturing. The understanding, which is an R&D issue, the understanding of material behavior in additive manufacturing will have to be relearned in a way compared to the usual subtractive manufacturing. How you test a near-net shaped product for certification, how you assess the integrity of the product in a live supply chain. How do you ensure the right surface quality for every product, and so on and so forth. And of course, how do you ensure the optimum use of material, and how do you design a complicated component from a 3D development perspective is a strength that India needs to develop. Next one, please. And I think this can be done not only by academia, but by incentivizing industry to be world-class in production of powders and attaining design expertise. And most of these industries will not be the big conglomerates. These will be MSMEs and slightly smaller scale industries, which will be nimble in their approach. So they could set up powder spray manufacturing facilities for powders, which would have design capabilities in a nimble way, working with OEMs, working with consumers. But they need to be incentivized, because this sector, although is very innovative per se, but cannot invest in new technology. They cannot invest in, because of their size, invest in R&D. And I think it has a huge role for the government, and as well as institutes like NIFT or even the CSIR labs to come in and play a role in creating this ecosystem of building the necessary capabilities in the MSME and the small to medium MSME and the small industrial sectors. And by small, I mean not very small, but not the big conglomerate. The big conglomerates can take care of themselves, I think, of this. And go global is the mantra. We need to be able to have the quality that the globe accepts. and be able to see the globe as the market. Next one, please. Can you just let me know how much time I have?
Sir, 20 minutes.
How
Almost
much?
15, more than 15 minutes.
More than 15 minutes.
Yeah.
Okay, thank you. So let me touch upon rare earths. I want to leave some time for questions also. So let me touch upon rare earths, which is again very strategic. Next one, please. So the use of rare earths in the world is increasing, and it's increasing because all the devices that we use today, the computers, the handheld devices, and so on and so forth, the magnets being more and more used in automotive, etc. The demand is rising the need for rare earths. Next one, please. And there is, lo and behold, Chinese dominance. Although it has 35% of the global resource, 84% of the world's rare earth oxide is produced, rare earth elements are produced in China. Although most of the bulk patents and developments have happened in Japan, US, and Europe, but China has a stranglehold. Next one, please. And because of their excellent electronic electronic properties, magnetic properties, and catalytic properties, the rare earths are mostly used in catalysis, in magnets, etc. And as we see growth in the number of electric vehicles, and this is the way forward for the whole world, it's a one-way street. Electric vehicles will become dominant mode of transport across the world. The use of magnets in the small motors will become, at the wheels or wherever, will become more and more prevalent. Also with the use of more and more handheld devices, the use of rare earths will become more and more prevalent. There is an increased demand of clearly increased market for an increasing market for rare earths. And where is India in this? Next one, please. Next one, please. So if you look at the India story, India has a few of the rare earth elements, monazite, for example, but it has very little manufacturing capability. India has the capability to beneficiate rare earth materials, but once it comes to making the element, from the element to a component, India has a huge gap. And going forward, rare earths are so strategic, India really cannot depend entirely on import rare earth materials. Next one, please. So we need to have, I'll go fast, so bear with me. Need to have public-private partnerships here to address these gaps, the oxide to metal gap, and I've already mentioned that India has the capability for beneficiation from more, but it's the oxide to metal, the metal to magnet, and then the recycling of the rare earth elements. These are so precious, we can't afford to throw away the rare earth metals as at the end of life of the gadgets. And it is in this recovery of the rare earths in e-waste and the recycling of rare earth elements where a huge focus must be put. And I know that National Metallurgical Lab has technology for itself, and I think it won an award only yesterday for its rare earth activities. Next one, please. Similar story with energy materials. As we go, next one, please. As we move away from use of oil to use of batteries, and I mentioned electric vehicles is a one-way street. It's and no puns intended. It's more and more electrical vehicles will be on the road, that's for sure. And therefore, the materials, the battery materials that are needed for these for electric vehicles will be increasing in demand, and there's a cobalt, nickel, manganese, lithium, etc. And all of these, or most of these, are predominantly imported. Next one, please. So we are, in a way, moving from one imported source of energy, which is oil, to another set of imported materials for energy. So going from oil to lithium, nickel, cobalt, which are imported from Congo, China, etc., and needle coke for the anode, which is mostly imported from China. And again, it is really up to us to develop technology within indigenous technology for development of even say needle coke. Needle coke comes from can come from coal tar. I mentioned coal tar before in the context of carbon fiber. Needle coke can come from exactly that source. And India has 100 million tons of steel, which will grow to 300 million tons of steel. So, and then the coke ovens will increase. So amount of coal tar will increase. So it is important that India develops for itself a needle coke technology indigenously. And that will serve in a big time the battery industry for the future. Next one, please. The lookout for battery materials could be India-based. You know, there are lateritic overburdens. For example, the chromite ores that we have in Orissa have nickel and cobalt in the overburden, which can be, we can develop technologies, and I'm sure along with AFMP, Bhubaneswar, and other institutes who have been working on this for several years, but we could accelerate those programs and take them to the pilot scale and then to semi-commercial scale, either hydrometallurgical route or pyrometallurgical route for extracting nickel and cobalt from the overburden material. We have lots of manganese ore in India, again in the Orissa belt. Purification of manganese ore. I don't think I'm showing that slide today, where we can see that across the world, battery grade manganese is predominantly made, surprise, surprise, in China. And there is no reason why we can't have a technology which takes our manganese ore and purifies it to battery grade manganese. And these are some of the initiatives that we as Tata Steel have taken to for future addressing these very, very important materials for electrification and for clean energy routes. Urban mining, as in the case of rare earth materials, is extremely important for these materials as well. You know, one of the benefits of having these materials, other than besides the CO2 footprint of oil, is that oil cannot be recycled, right? But these materials in the battery can be recycled if we have the right technology, the right price. So it's important that we develop and mature an urban mining recycling technology for batteries, so that we over a period of time decrease our dependence on imported lithium, nickel, and other battery materials. Next one, please. I'll finish off by giving an example of completely new material, which from a materials perspective is young. It's only about 10 years since it got it, 10, 15 years, got the Nobel Prize. It's a material with a lot of promise. It's worldwide, there is a lot of activity, and large-scale use is still to be found. But this is a material, and this is an example of how we can work indigenously in India to develop global leadership. So let's go forward, please. Yeah. So this is an indigenous route for, and I'm not describing the route. So we have an indigenous route, which is a Tata Steel intellectual property for making graphene from either graphite or from seedlac, which is a plant product. And we can make in different forms of different powders, with different powder types. It could be reduced graphene oxide, it could be graphene oxide, and we'll have multiple different uses. Next one, please. Yeah. So we have used graphene in beneficiation circuit in screens. We've used them in conveyor belts, in hybrid, in idler rolls. Next one, please. In graphene doped HDPE pipes, we have used put graphene in master batches to be used in rubber or in other products. We used graphene as coating on steel. This is a superlink, which is, you might have seen this as a caging device that goes around rebars. We have used graphene doped powder for coating on tubes, and have graphene in aerosol to be sprayed along various components to give them corrosion protection, hydrophilic or hydrophobic properties, etc. Next one, please. So in summary, so graphene is a story which is entirely Indian. We, as Tata Steel, are putting up world's largest graphene production plant, which is about 100 tons per annum. 100 tons of graphene is a lot of graphene. And it's coming up in Jamshedpur. And given the COVID situation, it should have come up in December. It may take a few more extra months, but watch this space. So I'll finish with this summary. If we look at the strategic materials and their manufacture and the position of India in the world, and the ambition that India needs to be self-sufficient and take a leadership position, we need a policy framework to be created to promote market for its materials. And this policy framework could be encouraging companies to go worldwide with their products. India should see itself as a manufacturing hub for the entire world. Encouraging through funding collaborative technology development between industry, government, academia, and very, very importantly, MSME. MSME really is the backbone of innovation in the ecosystem. They are nimble, they can focus on individual products, but they don't have the economic might to invest in R&D. The ecosystem must help them to do that, and it's for the benefit of the ecosystem. Ensure academic research supports technology development in new materials, and this will come through focus. If we have focused projects that will pull technology and research development through the value chain. And of course, this will then lead to strong pipeline of engineers in these fields. And I'll finish with this picture, which is a picture of collagen, which is the protein building block of the body. This will also be the building block of our nation's industrial footprint. It's a triple helix, not the double helix of the DNA. This triple helix of government, industry, and academia. But unlike the double helix, which is autonomous and dictates the rest of the organism, triple helix doesn't dictate. It needs to be dictated upon. So we have to find who leads in this triple helix. And I leave that as an open question, but there needs to be a leader of this triple helix to make the triple helix work. But that the triple helix is needed is beyond question. Thank you very much. Thank you for listening.
Sir, thank you for your outstanding and engaging talk. We have 2 questions already. We have got 2 questions from our audience. So can I raise that to you?
Yes, please, of course,
Okay.
please.
So first question, Mr. Sasank Srivastava, he is asking that kindly enlighten the challenges related to metal foams and MMC, especially related to lightweight structures.
Yeah, sure. Can you put the next question also? So that
next question, Mr. Ansuman Vez, he is asking that is sustainability lagging behind in the race of new technologies?
Sustainability. Yeah, okay,
Yeah.
right. So I'll take the first, metal foams. Yeah, so definitely metal foams is a way forward for lightweighting. I think you mentioned lightweighting in your question. But as the world has gone forward, there are many ways of getting to the same lightweight. Right? Metal foam means you still have to melt a metal, which means you have to precede that with a beneficiation step. You have to melt a metal. You then have to make sure that it has a foaming activity. And the foam is uniform in size. It will be open pore, it will be closed pore, depending on the usage. And it has to be ductile. It has to suit the purpose and be formable. Most of the time when you make metal foam, making the foam itself is perhaps not the most, I think people have already crossed that challenge of making the foam. It is the subsequent use that is the challenge, and its repairability, right? So most of the time when you put a foam, it will not be put by itself, it will be put as a sandwich, as a core of a sandwich or whatever. And then it has to take a certain shape. And giving it that certain shape would mean either machining or something more complicated to be done to it, which is cost. And repair subsequently is also an issue, right? It takes away foam's properties. I'm not saying foams don't have a future, but they will have a limited future. In the meantime, you will get foams, non-metallic foams. You will also get other light materials which can act with different properties. Some can act as heat barriers, some can act as sound barriers, some can just increase thickness to give stiffness without. So, yes, so I guess in terms of a large market, metallic foams will find competition with many other options. The other question was on
sustainability, sir. So whether sustainability is being compromised for the race of new technology.
This is something nobody can afford that is compromise sustainability, either in new materials or in legacy materials, right? Such as steel. With new materials, and I mentioned, for example, rare earths, I mentioned carbon fiber, I mentioned battery materials. All of these materials, we need to find out two things. We need to find out their CO2 footprint, right, in the manufacture of it, and try to reduce. Of course, I'll touch upon CO2 footprint a little later. The other part that we have to be careful about is the end of life state of this material. There is no way other than recycling. Even if it is downcycling, that means not to the same level of use, less level of use, but we just cannot afford to dump these materials in nature. We have to find a way of reusing it for better utilization of resource, one, and secondly, to reduce contamination in nature. Right? So as I said, urban mining, which is recycling both of battery materials and of electronic waste, is absolutely imperative, and we need to find our own technologies for that, for our own sustenance. Similarly, in carbon fiber and other composites, we need to find a way of reusing carbon fiber, to make maybe not the same, maybe not aircraft fuselage, but could be aircraft seats, right? So we need, and that should be an integral part of the product development or the material development program. The other part was the CO2, so which is equally valid for legacy materials and new materials. So the world does not today have an answer for capturing all the CO2 that we give off, man-made CO2. So the technology development is happening and will continue to happen. So over the next 3 to 5 years, we will find a scalable technology to capture CO2, and then what to do after you capture CO2, right? So that solution also has to be found to to either sequester underground, which is not very favorable, or to put that CO2 in a product, in a compound that can tie the CO2 down for a long period of time. So for example, put the CO2 in a protein molecule and you put that in food, right? Eventually it comes out through the breath as CO2, but at least it's gone through as a food and it's in your body. Or you can put it in other say in polycarbonate, for example, and you make polycarbonate sheets out of it. Has a long life cycle. So some such solution has to be found.
Yes.
And I think worldwide there is a lot of activity that's happening in this area.
Yes. So in between, let me take this opportunity to ask one question myself. I have one small question, sir. Actually, you mentioned about that carbon fiber making. I wonder that when we have such a large production of coal tar, and coal tar can be converted to carbon fibers, then when the market is not there in our country, and in the global aspect, we have a market. So why don't we, because we have a global leader like Tata Steel, Tata Group, so why don't we take up this challenge as only depending on the export for the time being? We set up the new technology and start developing, carbon fibers in our country, only based on the export, and slowly, subsidiarily, we will grow our market in India, because that will, and in that case, the driving force for creation of market in India by replacing some, already existing material by carbon fiber will be much higher than if we sit simply and we'll wait for the country to go to a better, market position. I believe so. So, what is your perspective, sir? What is the basic hindrance between that?
Yeah, I agree with you. So let me build up this answer a bit. As I said, you have to have a global view. In many of these materials which have low market size in India, you need to have a global view for the market.
Yes, sir.
There are two things that are needed for any large company to come in and set up manufacturing. One is market, and you and I have solved that problem. We'll say, look abroad, right? So, look abroad. Assuming that there is a route to going abroad. So it's not an easy route, but supposing there is a route, the other part is the technology itself, right? Now, either we invest in developing an indigenous technology, or developing on an indigenous technology, if we consider NAL,
Yes.
right? Or we join hands with an established technology provider, such as, there are many, some from I don't want to take names, from Japan or US, there are some. And there's a price and cost to it. There's also a limitation to it. So that's a call one has to take. So internally, the Tata Group had been in carbon fiber for some years, but we have limited ourselves to the use of carbon fiber to make aircraft components, mostly aircraft components. Only lately we have moved out of that domain of only use carbon fiber only for aircraft components, mostly for aircraft components, to broadening ourselves to composites in general, right? And we have taken a view that we probably need to have our own technology. So we are working on possible routes through coal tar. Yeah, because PAN is already filled with IP.
Yes.
The technology is so well established and so well guarded.
Yes.
You'll need much more intensive research to break the PAN. So it's easier to hand. You can get that anytime. If you want to go ahead with PAN, you'll partner with somebody who has the technology.
As you are, sir, related to
we are working on
industry person you are. That's why I'm asking you that don't you think that Indian companies, big companies or small companies, they are a bit reserved to take some risk for newer technology? Isn't it, sir?
That's a general point.
Yeah.
So yes, so I'll finish the previous question by saying that yes, we are in the way, we are along the path now to working on carbon fiber from coal tar pitch. So there's an active work in our company. To answer your second question, which is whether Indian companies in general are risk averse. So it's a question of what is so when you take a commercial decision, you'll weigh out the risks. Risk of every decision you take has a risk.
Yes.
You know, and I can simplify that decision by making it a buy or make decision.
Yes.
If you buy, you have a risk also by being subjugated to something somebody else has done, right? And make also has risks which are associated with doing something novel,
Yes.
right? And at any given time, it will depend on extraneous factors as to which risk outweighs the other one. In cases where getting things from somebody else is either not possible or very expensive or geopolitically not possible or something like that, Indian companies have invested and done something for themselves and done well. And especially and I'm not saying companies here, say the government initiatives in atomic energy and space are examples. Yeah, we have developed our own, for us. And we are the world leaders in what we have developed. In companies, there are multiple which, our agricultural revolution, which has been more of a social, our milk revolution again, has been indigenous. But when it comes to manufacturing products, we have mostly veered towards buy than make, because buy gave us huge leaps of technology at that point in time. And I think we have come to a crossroads in history where we have to think very deeply when you're making a buy or a make decision. And I think the environment today is quite ripe to take a call on positive call on leadership.
Yes. Yes. So, sir, another question from. Let us take. Many questions have been asked. Let me tell all the audience that your questions will be answered in consultation with the speaker after this talk also. Okay, you will be conveyed your answers. No problem, no issue. So, Mr. Nimai Chandra Gorai, he is asking that why we are lacking manufacturing silicon wafers through the domestic market, though the domestic market is large for manufacturing scale.
So sometimes when sometimes technologies bypass us when you're dilly-dallying on decisions. Many technologies have bypassed India. Right? Two of the predominant ones are the whole electronics manufacturing technology, semiconductor chips and all that bypassed us. We can get it back, but we'll get it back after others have already reaped the harvest. Right? So we will get it back. Other conditions. The other big technology that bypassed us is the solar technology, the solar cell technology. It was funded essentially not funded. It was encouraged essentially by Europe, specifically by Germany, through huge state grants and subsidies and all that. And they made companies viable through the subsidies. But what they did was they made that innovation democratic. The innovation became part of public. There were huge solar farms that were set up. And it was shown that if you increase volume, prices drop. Now, once that was proved, China took up production of solar cells. And what they do in scale. Yeah, so once they took up silicon wafer making for solar cells, there was no looking back. They make about 95% of the world's silicon wafers. and that at that volume, at that price point, it's no industry will survive across the world. So the German industry doesn't exist anymore in silicon, although they began the first sort of democratization of the innovation, so to speak. And I think India has lost that wave. It can get it back with a bit of struggle and tariff barriers, but it has bypassed us. What we should not let, more importantly, from learning of this, we should not let us be bypassed is in the battery materials. I think even the rare earths has bypassed us. China has 85% grasp on that. We should not let battery materials handling and recycling bypass us. That technology, we still have a scope and we should lead that.
So Mr. Imran Khan is asking that what are the steps the Tata Group as industry leader is taking in this race?
What
What
steps?
are the steps? Yeah.
Okay. No, we are active in the battery area. We are, as a Tata Group, there's a whole chain. So Tata Motors is creating the market. Tata Motors has an active electric vehicle policy, active electric vehicle strategy. So the personal vehicles, the PV, the four-wheeler cars, etc., will be battery driven. And most likely the bigger vehicle, the buses and the trucks will be fuel cells, so therefore hydrogen driven. For the battery materials, Tata Chemicals is going big on producing the battery materials. So they will be working on producing the batteries also. And we are initiating work with Tata Chemicals as a partner, and the talks are still going on. I cannot say that it's been signed yet, but it's on the table. So for recycling of battery materials, etc. So the group is active, and you'll see some work in the battery materials area.
Okay, sir. Those are some of the major questions actually. There are many questions like Dr. Anand NS. He is asking that can you shed some light on the commercialization of aluminum matrix composites in automotive and aerospace industries? And his second question is in particular, a continuation to that, in particular, aluminum matrix carbon fiber, CNT and graphene composites.
I would ask back, why aluminum matrix? Polymer matrix does fine, and in terms of if you're putting carbon fiber, it might as well be polymer matrix. The temperatures are lower. You can control the systems better, and you get the stiffness and strength as good as steel. So why not polymer matrix composites? The aluminum matrix short fiber composites like whiskers or something. The uniformity of distribution becomes an issue, and high temperature also becomes an issue especially when you're comparing with resin matrix. So unless there is a very specific property needed for general purpose use in structures, I think polymer matrix composites with long fibers and even with fabric would be the way forward, especially for automotive and most mobility.
Thank you, sir. Thank you for your nice answers. We can. There are many questions, so I can assure all the audience that you will be answered properly.
The questions.
No problem. No problem. We will be answered properly. So, sir, your talk was wonderful, and really we enjoyed the entire talk. And basically, you shown the fields where the two major challenges. That first of all, India to become self-reliant, number one, and second, that India to become global leader. How is it possible? How it is possible? and where we are lagging, where are the challenges. So it's wonderful. I know for the audience, I think whoever are interested to take challenges, it is very, it can motivate them in a large extent. Thank you, sir.
Thank you.
I am extending over to our director, sir, if it is sitting there.
Thank you.
Thank you, sir, for your nice presentation.
Thank you for your kind comments. Thank you, Dr. Chattopadhyay.
Welcome, sir. Yes.
Thank
You
you,
have a
Dr.
famous-
Bhattacharya.
Yes,
For sharing your enlightening views with all the participants. Right now, it is more than 115 number. So I believe this is.
It was 200, almost. I checked, almost 200 thoroughly.
I
I'm
enjoyed
sure.
it.
I'm sure this will help in big transformation in their mindset to look into those areas which are known but sometimes ignored. And what I find, there is a clear undertone in the direction of self-reliance of India, and indeed, it also hints that that is to be driven by knowledge sector, and knowledge sector accordingly need to focus their attention in that particular direction. So,
Yes.
with all these messages, I think we will find bright days in Indian manufacturing ahead. Thank you.
Thank you very much. Thank you for invitation. It was a great pleasure talking to all of you. Thank you. Bye.
So participants, we have a next session at 5 o'clock. IIoT, the enabler of advanced manufacturing. We look forward to all of you to be present in that session. I will take a 10-minute break. Thank you.
Thank you. Bye bye.
So,
পরে কথা হবে